Welcome all to the first session of Excode, which means that at the end of today, you'll be halfway through your Excode journey. As always, we start with the feedback. So thank you all for putting that feedback at the end. It was really helpful. It's still quite good. The two main things I've took a little bit was some people told me the lecture was a little bit too fast. That was quite recurrent. So I've tried to probably take 5 more minutes for this lecture to make sure that the foundational concepts are really conveyed through. And then I've also had some problems with people checking in. So now I've used a smart check-in system that we will take as a case study also for this week. This week is all about structure, and it's called finding structure. So we talked about variables, and in this week we'll talk about first a general introduction of data structures. Then we'll talk about 2 examples, lists and dictionaries. And we'll study, as always, 2 applied fields where we can use the learnings directly for research or for study or actually for real projects. So, data structures. We talked about the concept of variables, which is a box, you kind of get it now, you put something in it, you can get back what's inside. But in a computer, there's actually more than a variable. And I can take an example. If I have my phone here, it's probably tens and tens and tens of order of magnitude more variables than there was to the entire Apollo mission that went to the moon in the 60s. That's how many variables a simple phone that we all have in this room can hold. So often, it looks more like this, or even this. I could zoom more, but I don't want my presentation to crash. But actually, it's much, much more variable, much, much more boxes. So this week, we're talking about what we do and how we can arrange all these boxes as data structures. We're going to start with list. And I think that a lot of you liked the box analogy last week. I've got that in feedback. So this week, got plenty of boxes. Because I think that will make the concept so much clearer for you all. So we're going to study how, when we have more variables, each of these boxes present a variable, we can use them to then arrange those. So the basic data structure is the simplest way you can arrange boxes. It's a shelf, and it's called list. So you simply have a shelf, and you have all the boxes one to each other. That's it. That's a list, and so that's several variables, one to each other, ordered. So 1, 2, 3, 4. So here we say that usually when we create a variable, we assign a variable name and then a content, so what's inside of my box when I open it. When we're talking about a list, it is not the most convenient way of giving a name to each variable. I'll give you an example. Here at the Excode library, there's plenty of books. We can kind of say that every one of these books represents a variable. If I want to find a book, and if I look at the map, I will not have the name of every single book on the map. It makes no sense. What I'm going to have is a number system. So I'm going to have a number for each row, and when I'm on a shelf, I'm going to have a number for each book. It makes it much simpler for me. So that's exactly how it works with lists. Here we go. We have a number that represents the name of each variable. And what's the simplest way of putting it is to represent its position. So in programming, something really important, we start counting from 0. There are reasons that are a little bit more advanced. It makes more sense on the long term. But basically, so the first item is going to be at position 0. The second item is going to be at position 1. So here we can get our post-it. So take here. We have a number to each one of our boxes, like this. 0, 1, 2, and 3. When we have 4 boxes, our last number is going to be 3 because we start counting at 0. So that's a list, conceptually. So for instance, if I want to create a list of primes here, I'm going to have the name, which is a number. So this is a 0th element. And inside of it, I'm going to put an integer, which is the number 2. Here is the second element. So its index, its position is 1. And what I'm putting inside is the second prime, which is 3. So that's a list of prime numbers. And that's conceptually a list of prime numbers. So the numbers above looking a little bit of faces, a little bit confused. The numbers above are what we're putting inside of the variable, and the number in front are the positions, so how we call them. So this is extremely useful because then I can change this box. I can take a box out. I can move box. We're going to study that. So now moving toward code, this is more the representation of a variable in code. Usually what happens is we use square brackets to represent list. So I meant list. So do you remember in programming, usually we have like a key symbol to represent each thing. So an hashtag was used to represent a comment. So quotes used to represent strings. Simply numbers represent integers, and dots floats. And here, square brackets represent lists. So lists are kind of like a variable. So you say the name, so the list name primes. You use the symbol equal, and then you assign it to a list, so an actual several numbers. So this is creating a list of primes. As you can see here, I don't have to give a name to each one of my boxes, because automatically the programming is going to say, okay, the 2 is at position 0. The 3 is at position 1, as you can see by the above diagram. So here I'm creating a list that holds 3, 4, 5 numbers, and they are the first 5 primes. Do you follow me? That's good. I can do that also for a list of strings. For instance, if I want to store 3 really famous programmers, I'm going to have here, I create the name, so the name is programmers. You use the equal sign to say that I'm creating something and setting equal to a value. And the value of that, square brackets means it's a list. And then the 3 items inside of our list, the 3 boxes, are going to be Ada Lovelace, Alan Turing, and Tim Berners-Lee, which are 3 really famous programmers. Here, it's a general way of creating a list. So usually, it is something we call pseudocode. It's not actually code, but it's conceptually. You have a first item, then a second item, then a third item. And each one of these items is going to have a position, which is 0, 1, 2, and we go over. We have a lot of things we can do with lists. So working with lists. These are cheat sheets, which are things like a list of all the ways we can work with lists. We're going to now look at them individually. And then we're going to look at an example. So an Italian chef, I want to make, maybe it's better like that. I want to use code to manage his restaurant and his menu. And we're going to see how we can use lists to work with his customers. So now we look at the code. And now it's going to get clear, hopefully. So if you go on the lecture code, you can always find all the material and use those also during your workshop. So here we can start by creating an empty list. So this is just creating an empty list. So then if I print it, it will always take a little bit of time to connect. So if I print it, it's simply an empty list. There's nothing in it. It's like having a shelf without boxes on it. And if I print the type, you're going to see that the type of this is a list. It's called a data structure, so a way of putting my variables together in a shelf way like. Here I can create a list of string. We can see these are all the boxes with what's inside. So hello, how, good. They're all one next to each other as a shelf. So I create this, and then when I print it, it gives back to me the shelf. So the same. I can do the same thing for numbers. And I can also mix this with several data types. Inside, I can have first a box with a number inside, then a box with some text inside, then a box with a Boolean inside. That's how we can work. As for instance, on a shelf, if I can have different items of different types together. So now let's study how we can work with lists. So what we're going to do is to make it really simple, we're going to create a list called 0, 1, 2, 3, 4, 5. So what happens is that each number is the same as its position. So the 0 is at the 0 position. It makes it extremely simple. So I create that list, call it number. You can use that to create your own list in the workshop. Just copy this, change the name, and change the content. We use a comma to separate each variable. If I print this, I have my 5 numbers. And then now I can access a specific number out of it. So if I have my shelf, and I want to take the first box, take it out, and look what's inside, I can do so. And the way I use it is I say the name, if you can see print numbers 0, and I make it bigger for people that maybe are at the back. So here, if I have to print numbers 0, I want this to be in front. What is happening is I'm accessing the 0th element of the numbers, and so hopefully it should print 0. That's it. If I want 1, it's going to take the first element of the list, which, as we start counting from 0, is the 1. We can continue like that and access them all. We can also start by the end. So if I take -1, it's going to take the last one, which is going to be, yeah, that's good. -2, it's going to be 4. I can also have something that's called slicing. So I only take a portion of it. So here I take from 0 to -2. So you recognize the square brackets means that, so there's a name, then square brackets means we access something out of this list. We have the 2 points to say the starting and the ending point. So it's like saying, I want all the boxes that are from 0 to the set to 2, excluding 2. So it's going to be 0 and 1. So if I do slicing, I use the 2 points, start and end, and I take everything that's inside. So here we can go, and if we print the number from 0 to 2, it's going to do 0 and 1. Because always in programming, the lower end is included, and the final end is excluded, the final bit. So the 2 is excluded, we don't take it. If we wanted to include the 2, we'd have to change it to 0, 3. So we have 0, 1, 2. We can do it also the other way around. So from 0 to -2. So it's starting at 0 and ending at -2. -2 is excluded, so 4 is excluded. So it's 0, 1, 2, 3. And we can also slice in the middle. So from 2 to 4, try to guess. It's going to be 2 and 3. 4 is excluded, 2 is included. That's quite important, and then we will see in examples why. Then we can work with that list. So we can add an element. Now let's go back to creating a new list called primes equal to the first prime. So 3, 2, 3, 5, 7, 11. These are the first primes. If I print them, that's a list. I can add an element. So I can say print appends.17. So here it's going to add 17 to our list. It's like saying, if I go to my shelf, I have only 3 boxes, and I add another box. That's what append does. And I put between parentheses what I want to add. So here I'm adding 17. So if I print it, you can see the same list, we've added something. If I do it again, it's going to add it again. We can continue as much as we want. But here we realize that actually the real primes, we forgot 13. So to add it at a specific location, we say insert at the 5th position 13. So the 5th position is, if it starts 0, 0, 1, 2, 3, 4. So after the 11. And you can see here, we have added it effectively. We can do more things. So we can work, there's literally plenty of possibility to work with lists. We can remove elements. I can remove 13. If I print it, it's going to be removed. So it's like taking a box out of our shelf. You can always think, can I do it with a shelf with boxes? If I can probably do it also with Python. So I can add a box into my shelf, can remove one, can invert 2 boxes, can remove it by position. So if I want to, I don't know, remove the 3rd element, which is going to be the 4th, here's the last box, I can remove it. And so it's going to say, OK, I've removed 7. If I print it, 7 is removed. I can remove the last element in my list as well, because I've maybe put 2 times 17, so it removes it, and it removes it. You don't have to learn all this by heart. To be fair, I don't know it by heart myself. What you do is when you will work on the workshop, what I recommend is you have the workshop here. You also take the lecture code, and you can look at it while you do your workshop. You can also remove all elements from a list. So prime.clear, you're just emptying your shelf. There's other things we can do. We can add 2 lists together. So if I have 2 shelves, I put them together. So I have a list 1, 2, another list 2, 3. Simply do list totals equal to the sum of the 2. And if I print that, it's going to merge the 2 shelves. So put them together. can continue, I can reverse the order. So if I realize I've done it in the wrong way, I reverse it. I can find the length, work with that length. So here the length is going to be 4 because there are 4 elements. Here on the table here there are 5. There are 5 here on this list. So if I print the length, it's going to say 5 because there are 1, 2, 3, 4, 5 elements in there. And I can also modify an element, so set it equal to something else. This is quite important. Let's say I create a list 5 with 3 numbers, 0, 2, 2. So I have 3 boxes, 0, 2, 2, and inside of these boxes, here I have the number, these 3 positions. So here I have 0, here I have 2, here I have 2. Realize, okay, I want to change that. I take it, say, set it equal to 1, and put it back. That's exactly what I'm doing here. So I'm creating a list 0 to 2, saying, okay, the first element, which is by the index, so it's going to be not 0, but 1. Sorry, the first element is going to be 2, because the first 0 has an index of 0, the first 2 has an index of 1, the second 2 has an index of 2. So I select by its index, so I say the element at position 1, this box, is going to be equal to 1. And then when I print it, we have 0, 1, 2. So I have a shelf. Each box on that shelf has an index, 0, 1, 2, and then I can change things around. I can give you an example. So I'm a restaurant owner, I'm a chef, and I have a menu, and of that I have 3 offerings. So I have pizza, pasta, and healthy salad. So if I print that, I can print it with concatenation. It's giving an error. Can someone tell me why do we have this error? And try and guess. Remember, always look at what the name of the error is. It's a type error. So it means that we have the wrong data type. Can only concatenate string, not list to string. So here what is happening is we're putting together a string with a list. Sorry? The data types are different. So yes. Yeah. And what did we study last week that could be useful? Data conversion. So I can use str, convert it. And here we go. I've converted it to a string, from a list to a string, and then put it there. And then your chef realizes that pasta's run out because we don't have, it's sold out, so we can remove it. So I say, okay, menu.remove pasta, and we have a new menu without the pasta. But people are really angry because they like the pasta, so the chef want to add a dessert. You can add tiramisu, so you do menu.append tiramisu and print that. For instance, we have here a very clunky interaction because it's on Collab, but in real life you will have the same logic, but just on an app on your phone. But the logic will be the same. And in here, for instance, if you want to change an element to show that the salad is vegan, you can say menu 1. So here we have menu 1 is going to edit this. I want to change it to vegan salad. So if I print this, I changed it. And I could do more things, so print the length of the menu, print the second item, or print if pizza is in the menu. We're going to study those also next week. Coming back to the presentation, we are a little bit halfway through here. We studied list. And I want to kind of add another string to your bow. So this was not in the list of things to study for today. But if you remember, how did we define strings? We define strings as a list of characters, one next to each other. So one really nice thing that we can do now is take all the things that we learn with list and apply those to strings. Strings are simply a list of characters. So it's not that equal of a comparison, but conceptually, yes. So if I have, for instance, a 4-letter word or a 3-letter word here, I have lol, L-O-L. These each in my string, which is a variable, this is the first letter, L, and it has an index of 0. This is the second letter, O, and then L. And then I can do all the things I can do with list, but with strings. I can remove a letter. I can change 2 letters, and maybe put a L, or I can add a letter in the end. I can do even more useful things, like capitalize my text. Let's say I want to capitalize a title. I can simply say dot capitalize, and I don't have to manually change all the capitalization. With your name on the Excode platform, I can put dot capitalize, so if you did not capitalize it, it looks a bit more nicer and more professional. So that's a bit how it works with list. If we go back to our diagrams, that's exactly the same. Take a username, Linus, and that's 0, the position. It's the same concept. And in the code, this is how we created a string last week, if you remember. So name is equal to, we use the quote to say it's a text, and then we put the content of our variable. So if you look at the code, not gonna go over all of it because I lost it the same last week. We can create a string here, name is equal to Lorenzo, and then I can put it upper. It's gonna be all uppercase, lowercase, I can capitalize it, I can take the length of it, I can do plenty of things. And like with list, I can take the first letter, I can take the last letter, for instance, or I can also count the number of times single letters appear. This can be useful because, for instance, one of the things I've done is when you have to submit papers for, you have to submit research, and you have to count the number of citation, you could put, for instance, it's a bit more advanced, but you could put, I don't know, count the number of parentheses here, and then you can count how many citations you've put, and remove those from your word count, something like that. As you can then also replace some part, like name.replace from low to li. This is not something additional. This is exactly the same thing we started with list, but done with strings. So it's still a shelf, but rather than having variables in it, we have characters, and then we can move that around. There's also a concept called multidimensional list. So to explain that quite simply, this is not required. It's more in the advanced and curriculum. So it's going to be in the intermediate part for today's workshop. Simply, it's the same exact thing, just you have list inside of list. So if we go to the library, there's not a single shelf. There are actually multiple shelves. So it's list with more dimensions. So it's literally just the same exact thing, just we have a lot of shelves. And so here we have an index for each shelf and then an index for each variable. So the first shelf is index of 0, and the first item in the first shelf is 0, 0. The first shelf is in an index of 2, and so the second item on our first shelf is going to be an index of 2 and then 1. This is not required, it's a bit more advanced. So if you want, you can look at the lecture code, look a little bit how to work with it on your own time. Everything's on the lecture code. And then actually we could expand this to many more, but this is beyond the scope of this course. But we can have an n-dimension list, a shelf inside of a shelf inside of a shelf. Here, in the workshop, in the intermediate section, you're going to have multidimensional list, but only as a depth of 2. So a shelf inside of a bigger shelf. So for instance, here, if I have some celebrities, I can have several shelves, one next to each other, and have like Zidane, Platini, Mbappé. So in the first one, by country, then Neymar and Pelé is the second country, then Buffon is the third country. These are 3 shelves inside of a bigger shelf, which is called celebrities, football celebrities. And I can have that in code as well. The code, everything is on the lecture code if you want to look at it. I'm not going to go over all of it because it will require an additional session to go over it for beginners. So as long as you kind of understand the concept, if you feel like to, you can look at the lecture code and try the intermediate section of the workshop, but this is not required to have the certificate. It is not going to be on the certificate session. What is going to be a little bit more important here is dictionaries. Dictionaries, what they are is really similar to list, but with a twist, which we're now going to study. We started that with list, it's a shelf, and we assign an index, or a number that represents each position to each box. But here with dictionary, and the names give it a little bit better, we don't want to have the default, like, we don't want to call each box by its position, but we want to give it a name. So for instance, going back to before, rather than having the first box at position 0, we want to have, like, give it a name, like, this is in a dictionary, this is why it's called dictionaries, will be this will be the word, and this will be the definition. So I can say, for instance, a word, and then that's the definition. That's another word, and that's another definition. So I still want to associate two things together, but rather than having just this position, this is going to give me more information. So dictionaries are really good when I have two information related, and I want to store them together. Like dictionary, I want to store the words with their definitions. We call this here key value storage. Why? Because the key, it's the definition in the dictionary, it's the key, and then we assign it to a value, and then from the key I can find the value, from the value I can find the key. And this is, for instance, a dictionary. If I want to save the dates where programming language were created, I say, okay, Python, it's the key, and then I have the date. Java, it's the key, and then I have the date. And I can show that in code now. So if I go here into, this is a section about multidimensional list. You can go it on your free time if you want. It's really similar to list. The only difference is we have a depth of 2. Dictionaries. So to create one, this is creating an empty dictionary. This is a kind of a pseudocode to create a dictionary. We just say, so here the symbol is the brackets, and the curly brackets, we call them. It's like in list, we have square brackets. In dictionaries, we have curly brackets. If you don't know how to do it with your keyboard, there is a shortcut. You can ask your workshop leader. And the way it works is you have a key on one side and then a value on the other side, and you associate one with the other. And there can be plenty of data types. So the key can be a string, the key can be a number, it can be a Boolean, and same thing for the value. So here, if we look at an example, we have, for instance, student grades. So this, I associate is student name with a grade. So Alice has got A, Papa's got B+. And I print that. I can work with dictionaries. So I can, as always, access an element. So student grades, Alice. So by the key, I take the value. It's similar to how in a list, by its position, so position 0, I get the box. The only difference is that here, I have actually written like the name of the person, Alice. And then I say, okay, I want Alice's grade. I take the box, okay, it's A. And I put it back. I want Bob's grade. Okay, that's B. That's really the only difference there is to dictionaries. So here, if I print that, it's going to say, okay, that's Alice's grade is equal to A. We can add elements. If I grade a new student, I can say, student grades, Eve, add A. So I can print that, and it added Eve to our dictionary. I can also modify items. So if I realize that Bob did a mistake, I can say, okay, no, you got A minus, not A. No. Or maybe it's better here, A minus, not B plus. I can remove elements for dictionary. I always can access it by the key, and I can also empty a dictionary, for instance, if I want. I can get all the keys, so he's getting all the keys, so Alice, Bob, Diana, Eve, or I can get all the values. As you can see here, as long as you have one of the two, you can work with the other. Usually, keys are unique, so you can only have one key for every value. But you can have multiple values that have, you can have multiple values that are the same. So here we can see the key, they all represent different students, but several students can have the same grade. As in multidimensional lists, there can be nested or multidimensional dictionaries, which are beyond the scope. You are free to look into that in your own time. As always, we're going to look at 2 applied programs. I want to take 2 examples, and a little bit recap the session first. So we studied data structure, which are a way of putting our variables. The first one is list, which is simply a shelf. And on our shelf, we have the boxes. We can move that around, and we do that by its index, which represents its position starting at 0. Then we have strings, which we studied last week, but strings are just a list of characters in a certain sense, so we can work with strings like we would work with lists. So changing a letter, adding a letter, changing that around. You can also have multidimensional lists, which are lists inside of other lists. And then there's dictionaries, which rather than having an index, have a key that is associated with a value. Here, for instance, I'll give you 2 examples. This is me doing a research. So I needed to do research about gender equality. And my teacher was like, get as many papers as you can. So obviously what I did is I created a bot that could go on the internet and search for thousands of papers for me. So what I did is I first used ChatGPT to generate 500 keywords. Then I created like a script that did go into a Google Scholar and search for each one of these keywords. And for each one of these keywords, took all the papers that were like rendered, that were shown on the screen, and took like the title, the abstract, the citation count. So here, and then it saves all these papers data into a dictionary. And then I do that analysis. I can show you. So here I have a list of keywords that's generated by ChatGPT. So these are all my keywords. Then my program takes all these keywords by one, searches it on Google Scholar, takes all the papers, and arranges the data inside of a dictionary. So you can see the key here is title, and then the content is the content of the title for a paper. Then I have authors, and you can see actually here we have multiple levels, because we have first level, then authors, it's another level. Inside of authors, there's a list of 2 dictionaries. So we can go really into multiple levels. For instance, here, concept is a key in our dictionary, and the value, it's a list of all the concepts. So for instance, here we can see that in a dictionary value, it's a list. It's not only a string or an integer. Is an example, and then I could do that analysis on that. Like I can automatically generate a word cloud. This simply counted the amount of words. If you remember, we use in a string, you can use .count. So I counted the most frequent words, and then I put those on the screen based on frequency. They are bigger as frequent they are. I can see the top topics, so count the number of topics, and then display that. Or I can have the papers by year, like this. Another work is in economics, which, for instance, in economics, I can use that as a list to save, I'm going to go over that quickly, but to save the evolution of prices. So how does the price evolve over time? And I can study based on variables. So for instance, how much overhead additional cost will I have? And based on that, I can say, okay, that's all my costs, or that's all my profits here, for instance, based on my costs. I can do that and go in multiple dimensions, and then find also how I can break even. For instance, having a list of all my costs and all my profits and how they interact one to the other. I can find what values do I need to break even. So how many items at what price should I sell in order for me to break even. So that's a little bit about the session. Now you can all go to your workshop room. Thank you for coming. The check-in code, sorry. To check in that's a code. So you can take this code, put into the platform, you go into week 3, you copy paste that, you put check in, and you put the feedback. If you can put some text, just tell me what was clear, what wasn't clear. And then you can go to your workshop rooms.